All right, time for a quick review of simplifying square roots. So check this out. Square root of 4 times 9 can be calculated two ways. I can multiply the 4 times 9, so that's the square root of 36, which we all know is 6. But I could also split it up into two square roots. Square root of 4 times 9 is square root of 4 times square root of 9. Square root of 4 is 2, square root of 9 is 3. And 2 times 3 is 6. Piece of cake. Now that second one actually seems like it might be a little more difficult, and sometimes it is. In this case, I'd use the first method. But this property is always true and can be useful. The square root of a times b is always the square root of a times the square root of b, as long as a and b are positive. If they're not, then this isn't going to work. But for all our examples, these are going to be positive numbers. So let's look at an example here. This, I would not want to use the first method. I don't want to try and multiply 25 times 49 in my head, so I'm going to split that into two square roots. Square root of 25 times square root of 49. That's 5 times 7, which I can do in my head. That's 35. And the square root of 4 times 5 is the square root of 4 times the square root of 5. Square root of 4 equals 2, but the square root of 5 doesn't simplify, so I would just write this as 2 times the square root of 5. Let's look at that again. Because square root of 4 times 5, I can write as square root of 20. But we just said square root of 4 times 5 equals 2 times the square root of 5. That means the square root of 20 simplifies to 2 square root 5. In general, we say a square root is simplified if it has no squares that divide its argument. In other words, no square number divides the number under the square root. This means that to simplify a square root, we want to find square numbers that divide the argument. Let's look at this one. Square root of 40. I could split that up into square root of 20 times 2, square root of 20 times the square root of 2. But neither of those has a whole number square root, so this was not helpful. We want to think about square numbers. So which numbers do have whole number square roots? We can do that by squaring whole numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9. So those numbers 1, 4, 9, 16, and 25 have whole number square roots. Those are called the square numbers. Just a quick aside, why are these called the square numbers? There's 1, there's 4, 9, 16, 25. We can make squares out of that many tiles. If I have 16 squares, 16 tiles, I can make a 4 by 4 square. So 4 is the square root of 16. Anyway, back to the square root of 40. I want to find a square number that divides 40. So we think back to what those square numbers are. 1, 4, 9, 16, 25, 36. And a quick check will recognize that 4 divides 40. So that's the number I want to use. I'm going to divide 40 up into 4 times 10. That I can split into square root of 4 times square root of 10. And the square root of 4 is 2. So the square root of 40 simplified is 2 times the square root of 10. Another example, square root of 48. Again, I want to think about those square numbers. 1, 4, 9, 16, 25, and so on. 4 divides 48. But in this case, there's a bigger number, a bigger square number that divides 48. Because 48 is 16 times 3. And I want to use the largest square that I can so I can simplify in one step. So I'm going to rewrite square root of 48 as square root of 16 times 3, which I will split into the two square roots. And the square root of 16 is 4. Square root of 48 is 4 times the square root of 3. See? Easy. This actually works the same way with variables, but it's actually easier with variables. Squares are easy to see with variables. A squared is a times a. A to the fourth is a squared times a squared. A to the sixth is a to the third times a to the third. So any variable to an even power is a square. And of course, a to the fifth equals a to the fourth times a. So if I want to do the square root of a to the fifth, I can think of it as square root of a to the fourth times a. And a to the fourth, as we just said, is a square. So when I split that up into square root of a to the fourth times square root of a, the square root of a to the fourth is a squared. So I can simplify that as a squared times the square root of a. Now, for our grand finale, here's a problem that has both numbers and variables in it. But I'm going to split this all up into separate square roots. So I'll write square root of 96, square root of a to the fourth, square root of b to the third. And I'll think about all these separately. First, I'll deal with the number. The square root of 96, I can rewrite as square root of 16 times 6. 16 is the largest square number that will divide 96. Square root of a to the fourth I can simplify, but I'm just going to hold on to it for now. And square root of b to the third I will write as square root of b squared times b. Now I'll split all those up into separate square roots. And then the squares I will simplify. Square root of 16 is 4. Square root of a to the fourth is a squared. Square root of b squared is b. So square root of 16 becomes 4. Square root of a to the fourth becomes a squared. Square root of b squared becomes b. And the other two parts I just have to leave as is. And as my last step, I'm just going to take all the stuff that isn't under the square root and put it first. And the stuff that is under the square root, I will combine under one square root. And we have 4 a squared b times the square root of 6b. There you go. Thank you very much.